Hi everyone! Welcome to the second part of the What is Blockchain Technology video. If you haven't watched the first part yet, we recommend watching it first. Now let's talk about cryptography. Cryptography is the study of securing information that allows only the sender and the receiver of a message to read. It is closely similar to encryption since the process uses ciphertext, which means unreadable encoded text. Cryptography is commonly used to encrypt and decrypt emails and other plain text messages. To do that, cryptologists use the asymmetric public key system. As mentioned in the previous video, every user needs two keys, the public key and the private key. All they have to do is that the sender of the message requests the receiver's public key, then the sender encrypts the message, then sends it. Once it arrives, only the private key will decode it. In other words, theft is pointless without the needed private key. The message is secure. Going back, cryptography applies to transactions as well. To ensure security, you will need to verify transactions, and that's where mining comes in. So, what is mining? Mining is the process that Bitcoin and several other cryptocurrencies use to generate new coins and verify transactions. Miners help validate those transactions. They prevent double spending and other problems common in fiat transactions. Mining is usually heavy since it needs computers with specific hardware such as the following: a graphics processing unit or GPU, application-specific integrated circuits miner or ASICs, a cooling system, and mining software depending on the method to complete tasks. There are several types. In return for contributing their processing power by maintaining and securing the blockchain, the computers on the network receive the coins as an incentive to the miners. Other than that, miners add a transaction to a list of transactions shown. They record past transactions and allow anyone to visit the history logs for transparency. To set an example, it's just like tellers inspecting checks to ensure all requirements and account numbers are present, examining identities and proof to see if the user has enough funds to proceed with that transaction. Now, let's learn more about blockchain technology by knowing its history. Blockchain can be traced way back to 1991, when a physicist named Stuart Haber and cryptographer W. Scott Stornetta released a paper entitled How to Timestamp a Digital Document. The paper discussed the immutability of records with a timestamping service using hash functions and digital signatures to verify the originality of a document, just like what we have discussed in the previous video. It was only when a pseudonym, Satoshi Nakamoto, published a white paper back in 2008 that blockchain made its public debut, making Bitcoin the first form of digital currency using blockchain technology. Bitcoin reached $1,000 in worth back in 2013. Then it continued to rise to $20,000 in 2017, which took over the news. Just right after reaching the peak, it suddenly crashed way down to $3,200 by December 2018, then reached an all-time high of $60,000 last April of 2021. Going back to blockchain, let's talk about the first generation called digital currencies. It's the generation that implements the concepts of digital ledger technology that allows financial transactions over the internet. Ethereum was proposed by a programmer named Vitalik Buterin last 2013, but it was only funded and launched by 2015. Then smart contracts were introduced. It allows developers to build and operate decentralized applications that users can interact with. It is a blockchain that supports coded programs. Examples of blockchain are Ethereum, Binance Smart Chain, Cardano, Solana, and Tezos. Alright, congratulations on finishing the course. You now learned the fundamentals of blockchain technology. This is Jame, and see you in the next one.